Standard normal probabilities. So let z equal a standard normal variable. Now this is going into z-scores and the normal curve. Okay? The title of this topic is called Standard Normal Probabilities. So let z be a standard normal random variable. Calculate the following probabilities using the calculator provided. Round your answers to at least 3 decimal places. So the first one we're going to do, probability that z is greater than negative 1.97. Well, here's the picture. This is a normal curve. It's bell-shaped. The mean is in the middle. And then it stretches in the same amount in both directions. It's symmetric about the origin, or about 0. Okay? The z-scores are this graph divided up into standard deviations. Now we talked about this back the first week of the quarter, where the standard normal curve has 0 for the mean, and it's spread out 1, 2, 3 standard deviations and a little bit. So this minus 1.97 means 1.97, almost 2 standard deviations to the left of the mean. That's what this negative means, is to the left. So there's the picture. In ALEKS, we're going to use the key probability that z is less than a certain number. And then we'll plug in our values. Okay? Now notice, once again, ALEKS has this less than or equal to. Well, we want a greater than. So we're going to have to do a little song and dance to get that less than or equal to from ALEKS to say what our problem says. So we're going to use the probability that z is less than or equal to this negative 1.97. And that comes out to 0.0244191853. Okay, so we round that. But ALEKS gave us less than, we were asking for greater than, so we want the other side. See how that's what's shaded? So we're going to take 1 minus that value, which gives us 0.9756, which is finally the answer to the problem. Okay? So you can tell that this area to the right is pretty big, so it makes sense for it to be more than 0.02%. It's more like 97%, this all shaded area. Okay? So now our second problem, the less than or equal to 1.7, that's kind of straightforward. That's going to be exactly the answer that it gives you. So let's look at the third one. We need to find the probability that z is between 2 numbers. Okay? So the probability that z is between these 2 numbers is the probability that z is less than the big number minus the probability that z is less than the little number. So here is the objective function. This is what we're looking for right here with the shading in the middle. Well, the first one that we can get is the less than 1.89. And then if we were to take off this z less than negative 1.23, okay, that's like this white section. If we remove this bottom tail, then we would remove that white section and get the objective function. So remember, there's a minus sign in between these. So we're going to use the calculator, and we're going to get the probability that z is less than or equal to 1.89. When you plug that into the ALEKS calculator, we get 0.97062102. Minus and plug in the negative 1.23, and we get this number of 0.109348555. And when you subtract, that's 0.861, which is the answer. Okay? That's the area between the 2 numbers.